All right, in this video, we'll be talking about the electrical equipment PowerPoint. Try to go through this one a little bit faster because we already talked about generators and how they work a little bit. But we'll talk transformers, some of the switchgear, safety mechanisms, what a VFD is, some of the storage components. I'll skip through that too because we don't do so much of that, and then general safety items. So talked about generators. They are generators. Sorry, they are the electrical device that converts that motive or mechanical power into electrical power. Um, they are our source, or they're a source of energy. We either have sort of thermal or some sort of motive generators that we deal with. Again, we talked about all that stuff, so I'll keep moving forward. Some of the bigger generators you'll see on large sites for backup power are what we see here on the left. This one's smaller for more typical lighter commercial applications, then again for temporary use. So again, we put in generators as energy backup. Big thing to know is, obviously if we have any kind of emergencies, that's the only time we should be tapping into those backup generators. We use when the power grid goes down, or wherever our source of power is that goes down. So generally what we need to put them on is any kind of life safety measures. So lighting, so we have a safe path for people to get out so they can see. Elevators, so that our fire rescue teams or whatever emergency rescue teams have access to the elevator alone so they can get through the building as needed. Fire pumps are also important, that if there is a fire in the building and we lose power, that those pumps have backup, that they're on the backup generator. Okay, temporary generators, obviously we need to power up a lot of things throughout the construction process as well, not just tools, but we have to be able to see, and then a lot of heating or any other kind of climate or atmospheric control during construction. So like humidifiers, dehumidifiers, negative air machines would be pretty common, or air scrubbers, something to clean the air, their filters basically. So that's what our generators look like. Power bridging is an important concept when it comes to power generation and safety measures. Typically, when we have a power outage, generators have that slight delay in power startup, so we can have a lot of problems that come up with it. So I always like to use examples of healthcare and hospitals. So if we have people who are on life safety measures and power goes out, we can't have those life safety measures stopped. So we need to be able to bridge that gap. We do it in a couple different ways. We use different battery backup items, or we use UPS, so uninterruptible power supply systems. Generally use both. So these battery backup items for power bridging, a lot of times you see those on like individual equipment. So for instance, if you're in a hospital room and you have, some sort of life safety support thing that you're dealing with, like a ventilator. If you lose power, the ventilator battery backup will automatically kick on, and it's only meant to kick on for a little bit to sort of bridge that gap before the big energy generators kick on and are running at optimal power. UPSs are for the whole system in general. They can operate in a lot of different ways. You have a standby, you have line interceptors, or you have online ones. Further we get down the list, the more efficient they get, the more costly they get. So standby is pretty typical. Line interceptors are the most common though. They provide that voltage boost without accessing any kind of batteries, and they are pretty immediate. So you'll see that quite often in your projects when you have any kind of power bridging needs. Your transformers are that electrical device that is converting, or it's, sorry, not converting, but we're changing the amount of energy that we have. We're either increasing or decreasing the voltages within the electrical power supplies. So we have, voltages talking about pressure differential. So what your transformers are doing are changing the pressure differential, so we can either increase or decrease that power. So transformers look something like this. So you might see something like this at a larger process plant or industrial type facility or heavy commercial. We see these all the time. Then again, going back to dad jokes, another transformer, different kind of transformer, not sure how those work. We have another video here for you to see how transformers work. Pretty helpful to see how they change that power. Once we get in our building then, the switchgear is sort of like the main operation. It's kind of like the beating heart of your facility. Right, this combines all of the electrical components within your building, all the disconnect switches, fuses, circuit breakers, whatever that might be, and it helps control, protect, and isolate all of the electrical equipment that you have throughout your facility. So your switchgear looks something kind of like this. Each of these different cabinets house something different that controls something different. It's basically a large distribution panel, but it controls all the equipment within your facility. The next step would be a distribution panel. So these are components that divide and distribute electrical power feeds across into subsidiary circuits. So we're branching out now and getting to branch lines. This is providing circuit breakers and or fuses for each of the distribution pieces. Also important to note that a panel board and a distribution panel are the same thing. So again, terminology that gets interchanged. Your distribution panels look something like this. This is more of a commercial application where you have the breakers inside the panel here. This is what you'd see more in your house, residential applications. It's important to note that identification is a really big deal. On residential homes, I'm sure a lot of you have seen that maybe they're not that accurate. People add things, change things, update things, but don't really change this, so it's really hard to find out what that might be. In commercial application, that's really not going to happen so much because there's a lot of code requirements and people have to make sure that this identification is very accurate throughout, so we know exactly what circuits are covering what. Make sure you are properly labeling them. Make sure if you're building a house or you're renovating a house or doing anything in your house, you update your labels. Okay, a disconnect is an electrical safety switch. Moving right along here. So what this is for is to ensure that we have that electrical circuit to whatever your piece of equipment is de-energized to whatever that load might be, right? So the big thing to note here is we're usually only able to switch off a disconnect when there's no load present. So what that means is we would have to shut off that circuit, then go disconnect the load or the piece of equipment that we have the disconnect switch on, and then we can operate or do whatever else we need to do for equipment maintenance or install or whatever that is. These are isolated for individual pieces of equipment. They're usually right at or near the piece of equipment that we have. Sometimes you'll see, like in electrical room, especially in larger applications, sometimes you'll see a row of disconnect switches that are labeled for individual pieces of equipment. I'm not as big of a fan of that. I mean, they all come with their pros and cons, right? It's a good thing to see where all the disconnects are, but sometimes you're not sure exactly which one they're going to right off the top of your head. On the flip side, if you have them all right at the unit, you might not see them right away off all the time, but they're pretty easy to find. So I like them more at the unit myself. These are what your disconnects look like. So this one's pretty typical. So again, you have to de-energize the circuit first. So at the panel or at the switch gear, whatever is controlling that, you de-energize it, then you can shut your switch gear off, and then you wouldn't be able to turn that energy back on. Another form of safety are your breakers and fuses, right, just to ensure we're protecting against overcurrent. So they do pretty much the same thing. They operate in a different way, though. We don't want too much current moving through the system, so these breakers would detect that fault. That fault would be overcurrent in this situation. So once you detect that there's too much current coming through, they automatically trip and they break that circuit, right? So they separate the two wires within. Fuses, on the other hand, they would detect how much. They don't actually detect. It's just when you have too much current coming through, that strip of wire can't handle it, so it melts, right? And then that melting breaks the current. So older homes would have fuses. You still have fuses on a lot of pieces of equipment in your cars, obviously, stuff like that. Breakers are the more common way to go because you can just flip that breaker back on. VFDs, I mentioned this in a couple different locations before, but VFDs are variable frequency drives. What these do are they adjust the speed of the electrical drive and torque. They vary the voltage input and voltage output. So I put this in electrical because it is an electrical piece of equipment, although they're heavily associated with mechanical components and controls components, because the control systems operate the VFDs, which then talk to the pieces of equipment that they're controlling. So it kind of falls in everyone's plate. I throw it in here because it is talking about voltage, talking about input, output, and electricity. So a drive in this, what a drive is a component that controls speed of motion and rotation. So the main benefits of having a VFD is it reduces energy consumption and cost. It increases process control throughout efficient applications, and it extends equipment life and reduces maintenance needs. What this basically means is that if we don't have a VFD or any other means of controlling a drive, when a piece of equipment turns on, say there's a motor that turns on, that motor is going to operate at full capacity because that's what it's designed to do. Because as soon as that turns on, it's going to talk to, through the electric current, it's going to talk to the switch gear to say, I need this much power, and it's going to give you that much power. But if it only has to operate at, say, 50% capacity, the VFD is the thing that can control how much is actually needed to maintain that motor in operation. So if we don't have to operate it at full capacity, then we don't, and the VFD controls that. So your VFDs look something like this. Very typical. They're interchangeable. You can go from air handling units to pumps to motors to whatever else it might have to be. So that's why it's a little bit challenging with coordination. I like to talk about that too. So the big question is who has to furnish and install them, right? So this comes back to scope writing. So there's a lot of different uses for VFDs. Many subs might be capable of purchasing and installing them, right? And all subs are basically including controls on their equipment. So different subs may need the same exact VFD per the spec. So you might have one VFD that 3 different subs need. So then we have to determine, do we each buy our own and have them install their own, or do we buy a package unit and then do we coordinate that? Do we have one person that buys all of them and then they all install their own? So we got to figure out all that kind of stuff too across the board. Some and different projects require different things. If we have 15 VFDs, it might make sense to have one company, maybe your controls company, purchase them all. Sometimes they're right connected to a piece of equipment. So your air handling unit might have its own VFD right on it. So in that case, it's kind of a no-brainer. The air handling is coming with that AHU, so your mechanical company is going to get it, right? So that's kind of just going through that whole thing. So understanding that that's a kind of a big deal. They're expensive. They help a lot with efficiency and controlling your building properly. So a lot of coordination challenges, though, tend to come with VFDs, so just be aware of that. Another piece of equipment is a soft starter. So a VFD is obviously controlling once we are in operation how that's going to go. A soft starter would be limiting the surge of a current and the subsequent torque to the motor. Okay, so again, if something's turning on, it's saying I need X amount of power because that's how it's designed to run. It's going to be pulling all that load right off the bat. A soft starter maintains that current at a certain level once the motor speed is running at optimal speed. It provides a safer and smoother startup of operation. Equipment, again, extends the longevity of that equipment, so we're not just throwing electrical power at it right off the get-go. We're easing into it. So that's what a soft starter does. Electrical storage, talking batteries. There's different types of batteries for different applications. We have capacitors and inductors as well for electrical storage of energy through either electrical field or magnetic field, but we generally talk about our dry cell or lithium ion batteries, and this is just, I have some links here on how they work as well. Last couple things to talk about are obviously safety. So when we get into electrical safety on equipment, we have what's called a lockout and tagout. So this is a standard practice for all electrical safety. It is very specific safeguarding practice or procedure. It has to be very well detailed and organized. Everyone has to know exactly what it entails for the project. It's pretty similar, pretty typical, straight, right across the board. And what it basically does is not allow for any energizing machinery or equipment to take place while electrical work is being conducted for a unit. So for install purposes or maintenance purposes, if we have power all hooked up to the facility, we'd use a lockout tagout method of de-energizing a piece of equipment so we can go maintain that, so we can go work on it, so we can replace it, so we can install new, whatever that might be, and then nobody else has access to unlock it or untag it, only the person who's working on it. So it requires the individual doing the work on equipment or electrical circuit to de-energize that component. So only the one person who's doing that work can de-energize it. They have to lock that component with their keyed mechanism so no one else can re-energize it except them, right? It includes some sort of signage, right, for danger signage, and then they're the only person that can unlock or untag it after that work is complete and safe. So this is what lockout tagout looks like. So if you ever see that, that means someone is in there working on that component and it's off and there's no one else that can get in there because we've locked it. You will see multiple times where you have potentially many people on there. So in a situation like this, we cannot unlock this one until we have all three of these people come back and unlock it. So if one person's coming out and doing something else, they're going to take their tag off there. That indicates they are no longer there. We know that where they are now, but the unit is still going to be de-energized until everybody's out of the situation. The big reason, obviously, is we want to make sure that people are safe. You don't know where people are working all the time. You don't want someone to turn on something that they think is good to go. Want to make sure it's a nice, clear communication process because you need it in order to maintain safety. Other things dealing with safety is scope writing and how do we scope out different components when it comes to electricity. So cut cap make safe is always a big deal. It's actually for all of your MEPs, right? But because your MEP trades are the only ones that can actually that are certified to go in and de-energize your electrical circuits. They're the only ones for mechanical that can go in and disconnect all of the ductwork or whatever else they need to do. They need to coordinate with electrical just to make sure that we don't have, any kind of automation within there. Same thing with plumbing. Obviously, you want to make sure the pipes are cleared, dried in that location before we cut. So cut, cap, make safe. All the MEPs have to do that on their own before any kind of demolition or remodel work can be taking place. And we do an awful lot of demo and remodeling type stuff. So it's a coordination challenge right at the beginning. We have to make sure that all of our MEPs are on board with our demolition subs, with the contractor, with the prime, whoever that might be, to make sure everyone's ducks are in line here before we get started. So that's pretty much it when it comes to the equipment piece. I'll be back to talk to you about the wiring devices and components.